Good morning, Overall Middle School students. This is Mr. Woolley. And remember, the information contained in this video is intended to be viewed only by the students in Mr. Woolley's classroom. By watching the video, you agree that you will not record or share the video with anyone who's not a student in Mr. Woolley's classroom. All right, we're going to continue on with Lesson 4 today. Similar kind of concept to what we worked on in Lesson 3, the writing products as sums and sums as products. So how there's a relationship that exists between multiplication and addition, of grouping especially. Now, the first few examples here, I'm not going to go over every single one of these. Remember, when you have 2 times a quantity in parentheses, we use our distributive property. So essentially, we take the 2 times the x and the 2 times the 5. We get 2x plus 10. All right? Same kind of thing. If I have 3 times x plus 4, I get 3x plus 12, and so on. Now, how do you work backwards through these? Now, this will be one of our main focus points today, is say, for example, you got 5x equals 30, and we want to factor it, or go back to like a distributive situation. What we're going to do is we're going to try to find the biggest number we can think of that can divide into this grouping right here. And in this case, it's going to be 5. So I'm going to divide them both by 5. Now, 5x divided by 5 is going to leave you just x. 30 divided by 5 is going to give you a 6. So what you do is you put the 5, the number you chose to divide by, that goes on the outside. And in parentheses, you get your division answers, our x and our 6. So you can always double check your work. 5 times x is 5x, 5 times 6 is 30. So 5x plus 30 is how we got it. 8x plus 8, the biggest number I can divide them both by is 8. So 8's going to get divided into both of them. 8x divided by 8 is just going to leave the x that you see here. And 8 divided by 8 is just 1. So then, of course, we put our 8 on the outside that we divided by. And 8x plus 8, once we distribute, takes me right back here again. 3x minus 12, the biggest number we're going to divide them both by is a 3. So divide them both by 3, and you get x minus 4. And that's why we have 3 times x minus 4. Remember, the number that goes outside to multiply with, that's what you chose to divide by. If you're not sure, remember, just double check, redistribute again, make sure you end up with the same type of scenario. So hopefully you get kind of the idea here. All right, so here's just a few more of these. I'm not going to go over every single one of these. You guys can kind of figure it out just by looking at the examples. 72t plus 8. Well, the biggest number you can divide into both of them is 8. So 8 goes on the outside. 72t divided by 8 gives you 9t. 8 divided by 8 gives you 1. So 8 times 9t plus 1. That's how that kind of works on the setup there. And remember, by the time you get to stuff like this, where you have like 3r plus 3s, both divisible by 3, remember, 3 divided by 3 gives you 1 of the r's, but we don't put a 1 in front of the letter. So just leave it as the letter. All right, let's take a look at example 2. Let's let the variables x and y stand for positive integers, and let 2x, 12y, and 8 represent the area of the 3 regions in the array. Determine the length and width of each rectangle if the width is the same for each rectangle. So you have an area of 2x, an area of 12y, and an area of 8. Now, on area problems, you had to multiply length times width to get there. So we're going to work backwards. We're going to divide. I'm trying to find the biggest number that divides into each piece here, which in this case is going to be a 2. So there's my 2. And 2x divided by 2 leaves me just x. 12y divided by 2 gives me 6. 8 divided by 2 gives me a 4. And there we go. You can double check it, remultiply again, and you should get the areas that are on the inside. All right, now this problem, they kind of already had it set up and already done for you, but you just double check, like, oh, there's your areas again. Apparently 2 is the biggest number that they could pull out of all those, and then you get the 12d, 4e, and a 3. So there we go. We can set up as distributive, and you can redistribute again. You'll just see what the area is on the inside. All right, sometimes you get more than just 2 numbers. Like in this case, you got not just a factor, so we'll pull the biggest number out that we can. 48j plus 60k plus 24. The biggest number that divides into all of those would be 12. So 48j divided by 12 gives me 4j. 60k divided by 12 is 5k. 24 divided by 12 gives me a 2. So whatever number you chose to divide by, that's what goes outside the parentheses as you're grouping those. All right, so now here's some different formats of how we can look at some distributive property situations as well. All right, so here I have 2 times 3 plus 5 times 3. Now, due to the fact that both of these are getting multiplied by 3, I'm going to pull the 3 out of there, and then just leave behind the 2 plus 5. And if you want to solve that, I can get 2 plus 5 is 7, 3 times 7 is 21. Now double check your work. 2 times 3 is 6, 5 times 3 is 15, 6 plus 15 is 21, so we did it correctly. Now here's a little easier way to kind of visualize a distributive property scenario when we factor. You got 3 of the same group. So there you go, 3 of the 2 plus 5 groups. Still gives you 21. So, and then you got the similar setups on these next examples here. You got x times 3 plus 5 times 3. So what do they have in common for each chunk of multiplication? Well, they're both being multiplied by 3. So pull the 3 out, and what's left behind? X plus 5. And then obviously you have 3 of the x plus 5 groupings here. Similar scenario down here. We have x times 3 plus y times 3. Well, each chunk of multiplication is being multiplied by 3, so let's pull the 3 out of there and stick it out in the front. And you get the x plus y still left behind. And if you distribute, you still get 3 x's and 3 y's. So, all right, let's go ahead and take a look at how this would set up in a word problem. It says a new miniature golf and arcade opened up in town. For convenient ordering, a play package is available to purchase. It includes 2 rounds of golf and 20 arcade tokens, plus $3 off the regular price. There's a group of 6 friends purchasing this package. Let G represent the cost of a round of golf, and let T represent the cost of a token. Write 2 different expressions that represent the total amount this group spent. Explain how each expression describes the situation in a different way. Well, we let G stand for rounds of golf, and T stand for arcade tokens. So that's kind of like my initial things. The rounds of golf is going to be a lowercase g, and tokens be uppercase T. We don't like using a lowercase t because it kind of looks like a plus sign. All right, so if you did it individually, you get 2 rounds of golf and 20 tokens, then you get $3 trimmed off your price. So that's one package, but there's 6 people that want the same package because 6 kids are going. So it's 6 kids times the cost of one play package. Or if you distribute that out, if you want just the overall final cost, they're both going to show you the final cost. That's 6 individuals, and here's just 12, or the total people, and all their data. 12 rounds of golf. If you distribute 6 times 2, 6 times 20 gives you 120 tickets. 6 times minus 3, altogether they're going to save $18 for the total there. All right, now here's an important one. We'll see this pop up quite often, especially as we get to our future lessons, like lessons 5 and 6. What's the opposite of this chunk? Well, the opposite of an entire grouping, stick a negative sign out in front of it. Now, distribute that negative. A negative times a negative becomes a positive, and a negative times a positive gives you negative now. So you distribute a negative sign throughout the problem there. All right. Now, they want us to rewrite this problem in standard form, and they essentially want us to get rid of the parentheses and then total everything up. So 5a, you're going to take away the a, and then minus a negative becomes a positive, or if you don't think of them as a negative times a positive gives you a negative, negative times a negative is a positive, you think of it that way also. Either way, you end up with 5a minus a plus 3b. Well, 5a minus technically one of the a's leaves me with 4a, and the plus 3b is still just hanging out as the plus 3b. Okay, so we had a couple distributive scenarios here, and then collecting like terms. Negative 3 gets multiplied to each chunk here, and I get a negative 6p and a plus 9q, and since I have a p term and a q term, there's nothing else I can do with those. Stay as is. A negative a minus this chunk, well, minus an a is right there. Minus a negative is actually a plus b, so negative a minus another a gives you a negative 2 the a's, and then that plus b is all by itself. All right. Next up, we have a few more examples for you here. It says rate each expression as a product of 2 factors. This is like some of the other examples we did earlier today that I'm not going to go over all these. You can kind of see how they work. You have 1 times 3 plus 7 times 3, and then 3 is what you have in common between those. So factor out the 3, put that outside the parentheses, you're left with a 1 plus 7. And of course, here's another simple way to visualize that problem, 3 of the 1 plus 7 groups. So you can take a look at those and pause the video for a second, and I'll move on down to here. All right, so now in this case, they're not paired up like they were in number 1, but still it's really the same concepts. You got a 7 in each part of this problem, so factor the 7 out of it, put that outside the parentheses, and you're left with a 6 plus 3. So 7 of the 6 plus 3 groupings. Here's a little easier representation. You got 3 of the 8 plus 9 groups. So anyways, that's kind of the big idea behind some of these. And like in this case, you had 4 of the C plus D groups and so on. So pause it and look at those if you'd like to. Another one of these rectangle kind of problems, you're going to figure out what the length and the width were. They give you the areas already of the rectangles, 15F, 5G, and 45. The biggest number they have in common that you can divide out all 3 is a 5. So if that's the case, 15F divided by 5 gives you 3F. 5G divided by 5 is just 1G, or just what we call G. We never put a 1 in front of a variable. 45 divided by 5 is 9. So that's how we found out what the lengths and the widths were. So here's our 5 we factored out. And if you remultiply those all back out, you should get your areas all the same again. All right. This is another opportunity to just look back at some of the skills we learned earlier in the lesson with factoring. What you want to do here is find the biggest number you can divide into those. 81 and 48, biggest number is 3 that you pull on out of there. And you're left with 27W plus 16 if you divide each one by 3. B, I didn't put it back in the proper format that we normally would, just due to the fact that they left it like this, and I'm just going to leave it like this for now, but it was on a test, I would put the T out front, but 5 is visible into both of those, so you put 5 times, then you got 10 divided by 5 was 2, negative 25t divided by 5 is a negative 5t. Proper format for that would have been negative 5t plus 2 by the end, but we're not too worried about that right at this moment. So, and of course, like for here, 12a plus 16b plus 8, you go ahead and divide each one by 4. 4 is the biggest number it can divide out of them, so that 4 goes out in front of the parentheses. Then divide them all by 4, and there you go. All right, and then I'm going to cover one more of these here. It says, Xander goes to movies with his family. Each family member buys a ticket and 2 boxes of popcorn. If there are 5 members of the family, let T represent the cost of a ticket and P represent the cost of a box of popcorn. Write 2 different expressions that represent the total amount of money his family spent. All right, so if you think of it as, like one of the earlier problems we looked at, an individual scenario. Each person gets a ticket, so I use capital T, not lowercase t, and 2 boxes of popcorn. And 5 people got the same package. Or if you actually distribute it all out, you find a total scenario, you get 5 tickets and 10 popcorns. So there we go. Now, I'm not going to go ahead and explain these last pieces here, but you can pause and take a look at them. It's just more of the same kind of things. They're collecting some like terms a little bit towards the end of these a little bit more. But overall, you guys can kind of just take a look at these, get an idea what's going on, and I'll stop right there. So thanks for watching today, and go ahead and give your work a try in Schoology.